What am I setting?
And also plug the Apple TV in. Yeah, second one, yeah.
But then someone came up to me, saw my
And plug in the Apple TV.
and they grabbed me by the chain and they asked me to code they put me in the basement and forced me to work like every time I get home. No, it's someone on the internet.
They come by.
Yeah.
Can you get down?
I did. I did it.
Hopefully this doesn't break.
You won't care.
Hopefully it work. Uh,
You can.
That's like
Yeah. You can feel it works out. That's a fun sound.
nothing working today. Let's see.
Family thing in here, brother. Well, you got me. Genuinely, how would I have felt if the lock being in here?
All right,
But that angle.
it's working.
Sharpen everything.
That angle grinder. I gave it back. Who's gonna sharpen? We didn't have to grind stuff. It's just the person else.
Somebody need to open the door for him.
Run, Brian, run. No, no. Oh.
The Slender Man.
Okay, great. Nothing working.
Maybe the cords are on. Oh yeah, that's not yeah. Good call.
It's a flipping camera thing. Play the game.
Can you tell me how long you make the
I just want.
Oh, he's all right. Why are they three?
Here's the drill. Sure.
Here's the base.
It does not work.
I feel like when you work one of the left.
Good.
All right, so what happened is what we're gonna do is we're gonna talk about the last section. The last section is actually it's not as hard as people think, but I actually create a certain way to help you solve the problem. But first we need to have visual. So first of all, we're gonna talk about the QuickTime. Hopefully this one working now. Nothing working on my day today. I apologize. Oops, that's not the one I want. This one, that one. Show up, show up, show up. Okay, there we go. All right. So we're gonna start with talking about area. Area is area between the curve. And so let's just say if today I have y equal to, let's say it's 4. And it says y is equal to, let's just say it's x squared. Okay. Do you guys know how to graph this? You guys know how to graph this? Okay, can you graph it? So if you graph it correctly, it should have show up as this.
Thing in the way. Oh my frame rate!
And it should have like this, like this, like this, like this. How do I find the area between the curve? What do you mean by between the curve? Which one is between the curve? What's the area between the curve? Yeah. So is this graph, right? How do I find this graph? How do I find the area of this graph?
It's integral y equals 4, 2, and then bracket the integral of x squared.
Actually, that's really good. Do you guys hear what he said? It's actually what he said because he understands the area under the curve, right? Now, what happened is there was two parts of area under the curve. There was this area here, right? And there is this part of area here. Why? Because this is area under the curve of a parabola. Does that make sense? If you take this whole thing and take away this, would I get this area? Does that make sense? No? Yes, Samantha? Understand? Anybody's confusing?
Mr. Yamati says she can't see the problem.
She can see what problem.
She can't see like what you're doing.
Never mind.
She said
No, I think she cannot see it. So,
This is looking like some good 5 frames per second here.
is it slow?
So,
Okay, does that make sense? So what I would do is find the area between the curve. What I would do is, we know that, how do we know where to intersect? Ideally, if you don't know how to graph, it's really hard to find the intersect. So you have to know how to graph. But algebraically, you can find out where the intersection is. What do? If I want to find the intersection, I set both equations equal to each other. Does that make sense? Then x squared minus 4 equal to 0, x plus 2, x minus 2 equal to 0. And then x plus 2 equal to 0, x equal to negative 2, x equal to 2. So Alex says, well, it must be an integration from the -2 to 2. Okay, so we're gonna have this blue function. So why is it blue? Blue is a 4, right? Minus the red. So minus red, so minus a black, x squared. Why do I do that? Because I take it a 4. 4 is the area in the curve from here to here, which is we know is 16. But minus this graph because we want area in the curve. This is area in the curve here. So that's going to be x squared and then dx. And then voila, you got the answer. I don't need to evaluate this, but if I ask you to evaluate, you should be able to evaluate. But idea for, because of the purpose of how short the length of our lessons going to be, is I'm going to ask you to use calculator and evaluate it, because I don't want you to evaluate wrong and not matching the answer. Then you go back to evaluate by hand. It's something that's easy. So in this case, I will evaluate this by hand. It'll be 4x minus x to the third over 3 between 2 and -2. And this one is going to give you 8 minus 8 over 3 minus 4 times -2 is what? -8. Is that okay? Minus plus 8 over 3. Why is it plus? Because -2 to the third power is negative. So it end up to be negative times negative is positive. Now, a lot of time you try to combine fraction on both. No, you're going to look at the easier. So look at this too. Like, see, this is 8 and 8, but it's negative, negative, so it's plus. So it'd be 16. Is that okay? And look at here. It's going to be negative 8 over third. Subtract 8 over third. So it'd be negative 16 over third. Does that make sense? And therefore, it's going to give you 32 over there. Is this okay? Okay, so now I'm going to give you a graph. I'm going to give you, says, I want you to do f of x is equal to 2 minus x squared, and f g of x is equal to x. I want you to find area between the curve. Ideally, you're going to try to graph as the best as you can. But you should know that in general, if the negative x squared, the parabola is facing which way, right? Yeah, it's facing down. Good job. Nola, you still sick? Okay. Appreciate you coming today. But Nola, you have a question, please do ask. So I want you to graph it. I want you to find the area between the curve. The idea is always top curve minus the bottom curve. So the idea of area between the curve, sorry, I forgot to write this down, is integration of top curve minus the bottom curve. Okay, top minus bottom, if that help you. is on the top, the x squared is on the bottom, right? Or top minus bottom. Thank you. Teacher, nice.
He's pretty chill.
Yeah, you can.
Kind of strange request.
Yeah.
He was a little confused, but
¿Cómo se llama? Good friend.
he was people.
So,
Teacher.
Wait for the notch. You find the intersections first? Find the intersection. How do you find intersection? How do you find the intersection? Yep. So your graph is gonna have 2 minus x squared, so the vertex is gonna go up 2, and the y equal to x is this way. So a lot of you guys don't know how to graph. Okay? Make sure you know how to graph first. The x squared, let me go through x squared graph is gonna look like what? Okay. So you guys still have problem with graphing, but here's what I'm gonna do: is this graph that look at the components of this. This is negative x squared, and that's gonna be negative x go up 2 because this is up 2. Oops. My bad. This is gonna be up 2. Is that okay? So x squared is a parabola facing up. Negative x squared is facing down. So the vertex can go up 2 units. Is that okay? So it's gonna be 2 units like this. And then it's gonna face down. So we don't know how they graph like this, but that's okay. We don't have to know. But we do know that this part, we're gonna just put this part as a blue part. So blue. And y equal to x is the red part, which is the x. X we know how to graph though. Does that make sense? It looks like this, right? Now, we don't know where they intersect. So we say, hey, can we go find it? Can we go find the intersections? 2 minus x squared equal to x. Is that okay? Is this okay for somebody? Okay, I'm gonna move everything to the left side. So it's gonna be x squared plus x minus 2 equal to 0. That's equal to x plus 2 and x minus 1. Hopefully you guys remember how to factor. This is x equal to negative 2, x equal to 1. So they do intersect at negative 2. Now realize that, how many of you guys got this graph? Raise your hand. How many of you guys did not? Can you tell me where you don't understand? Carlos, do you understand?
Honestly, it was like the Y equal to 2.
Y equal to 2. Okay, so
But
the
then
t-
add everything.
yeah, 2 is going to go up 2 units. Negative x squared is facing down, let's go up 2 units. Okay? So now it's going to be negative 2 to 1. And then that's going to be, okay, well, we know that's that. But you say area on the curve. Doesn't matter. The area on the curve of here is going to be all here. So it doesn't matter. It's going to go all the way to like whatever. But the area on here is whatever here, right? So if I can subtract them two, the top minus bottom, then I can get a function. So the function is going to be the 2 minus x squared, parenthesis minus x. Now, why do I put a parenthesis here? Because sometimes depends. This parenthesis is very important. A lot of people don't put down the parentheses. When you don't put down a parenthesis, sometimes it's going to distribute. So then you're going to make a mistake. So I always put a parenthesis there. And also for lay down value, the parenthesis matters a lot. And this is going to be from negative 2 to 1. If you do it correctly, you should get 9 over 2. How many of you guys got 9 over 2 first time? Okay, good. All right. So let me give you another situation so that and sometimes I can give you the boundary from which x and which x. Okay, so we can give you this one. F of x is equal to x squared plus 2x. G of x equal to x plus 2. Okay, Aiden and Alex, can you help me bring that table up on the front? That table, that table is like a long table.
So once you drill the water well,
Why wouldn't we?
are you drilling it right now?
Yes. I didn't realize it was a private.
Actually, here.
Thanks for your help. Appreciate it.
You're welcome.
Thank you so much. Anybody want your watermelon today?
Where's Cameron?
Cameron's probably still hungry.
Growing goal. I need it. Or not. Is that generous? Yeah.
Now you're gonna say, how do I identify which graph on the top? You can plug in value in between, and you know which graph on the top. So this is another way you don't have to graph it. So if you find, as soon as you find an intersection, you pick a value in between, you know which one's on top. Plug in both functions, and you will see, okay, which one's higher. Then you know which one should be on the top. But if you did it the other way around, your answer is going to be negative. So you can use decimals to help you figure out what the answer is. And
Is
then
that x squared plus 2x?
x squared plus 2x, and the other one's x plus 2.
Okay.
I did not bring a knife to school.
My mom brings me to a pre-K class.
Really?
Yeah. They got pumpkin start following. Sarah teaching on it.
Yeah.
It's a culinary video.
Actually, anybody take this culinary? Here? I think I'm gonna tell my son to take it.
That's like a fun different shows. Yeah, because then you can just like order him to bring you the food they make.
Because I think like in the future, a lot of jobs will be replaced. I think chef is not.
I don't think it can be.
Alex, you enjoy it. You that out. You're one of the most people on earth. No. Sir, you kind of kiss me.
I did not. Does that sound like something I would do? That sounds like something she would be asking.
This generation, I don't know. This generation, I don't know. I'm not joking.
Is there a Wi-Fi?
I have a trouble with Mr. Yes.
So do I.
I just think
No.
Is there any?
I still can go both ways.
So then you start at zero. So
Still like, wow. Isn't that what dude like opens to people? He has a life. Mr. Yeah.
could you start at zero?
Doesn't your wife like have a tea shop at H Mart or something?
Yeah.
I was there yesterday.
Oh, you are?
Yes.
Do you like it or no?
Yeah, it's cool. I did go to the tea shop.
She works there.
Really? Yeah, no.
Kimberly is like the best customer service.
Like,
Kimberly would be.
I needed to buy a couple things. And I just went in and I was like, this is his wife, like, please here.
Own the place.
Not the place.
Is your wife the H in H bars?
Yeah. So own their whole H bar. Trust me, I won't be teaching.
His wife is John H. Bar.
I'll be like, sit
You're
somewhere.
married to John H. Bar?
Yes, I did.
Oh, why are you looking at me like that?
I was just not gonna grab it. Sure.
So if you're not able to graph it, can you find the intersections? That's the thing.
Yeah.
All right, and I will show you how to graph it, but so if I have problem graphing first one, it's actually easier way to actually factor out a x plus 2 here. And you know that graph is going to have something that's facing up of x and x minus 2. Something like this parabola is going this way. I don't know what is it, but it's a parabola facing that way. Because the x equal to 0, right? X equal to 0, that's going to give you the x-intercept here, and x plus 2 equal to 0 is going to give you -2. Because that's the way the x-intercept is. I only know this two graph, and I know it's facing up, so I know that this cannot be going down like this. It doesn't make sense, right? So if it's a parabola, it's only two x-intercept that's facing up, has to be the other way. We are going to, but I'm just trying to graph f of x. If I just graph f of x alone, that's going to be like this. X plus 2 is going to be probably like this. So x plus 2 is going to be probably this part here. And this is like this. Do you see that? Do you see that? Now, let's just say today, we didn't understand which one on the top, which one on the bottom. And that's okay. Because I can say x squared plus 2x equal to x plus 2. I said equation equal to each other. Did you do that? Because that's how you find intersections, right? So it'd be x squared plus 2x minus x minus 2 equal to 0. X squared plus x minus 2 equal to 0. Is that same situation as before? X plus 2 and x minus 1, right? So x equal to -2 and x equal to 1. Is that okay? So that's integration of -2 to 1. Now, how do I know which one on the top between those two values? You plug in 0, right? If you plug in 0, what will happen? One of them is going to be 0. G of x is going to be 2. Do you see that? It's 2. And one of them is 0. So we know which one's on the top. So it'll be top minus bottom. So it'll be x squared. No, sorry, it'll be x plus 2 minus x squared plus 2x. And I cannot emphasize how important that parenthesis is. because the parentheses will distribute. Now I will assume that this one is also 9/2. Is that it looks like the same graph? It's not? It's not? Okay. Might be, I don't know. I have no idea. So you can use the decimals to
Desmos said it was 3/2.
huh?
Desmos said it was 3/2.
Decimal says 3/2. Okay, I believe you.
Okay, I did something
Yeah.
wrong.
Let me make sure. So for your purpose, I don't want you to do it by hand, but you should know how to do it by hand. Because I don't have a lot of time, so I would rather you focus on your setup. AP exam is gonna focus on your setup, because they're gonna give you a point for setup. But so I don't, we don't have too much time to go over how to evaluate this. But just make sure you have a parenthesis when you type in. You need an extra parenthesis outside. So know how to use calculator right now. So using calculator is also very important. I got 9/2. Did you distribute the parentheses?
Oh, two as well. What am
I got 9/2 because it looks like same graph. If you look at it, just different orientation. Aiden, did you find out way around?
They just moved it left.
Or it's upside down too.
Oh, there we go. Check that out.
Is that okay? Did you guys get the same answer or no? Okay, I'm gonna rephrase what Sydney just told Brian. Is like if I don't know the graph, I find the intersections, right? If I find the intersection, great. If from -2 to 1, right? And then I can say, okay, well, I can plug in. I don't know if -2 to 1, which one's on the top? Is this on the top or this on the top, right? We don't know. We don't know which on the top. So we plug in f of 0. F of 0 is equal to 0. G of 0 is going to be 2. So G has to be on the top. So it's top minus bottom.
I just plugged it into decimals. I got 9/2.
Yeah, I got 9/2 too.
I just flipped the balance. So I said it was -1 and said -2.
Oh, okay. Yeah. All right. So sometimes I will give you the boundary, right? So for example, sometimes functions like this is actually fairly easy. But this one, I'll give you the x bound. I'll give it to you from where to where. Then you don't have to find x bound. You don't have to find the boundaries. So what if I have x equal to +2 and y equal to -x? X equal to 0, x equal to 1. So x equal to 0, x equal to 1. That means I'm just going to do from here to here. They already told you the boundary. So I want you to try to graph this and also graph x equal to 0 and x equal to 1. Then that way you know where the graph region I'm looking at. So try to graph it. If you can evaluate, but try to graph this one. I want you to graph all 4 graphs because our 4 graph is going to tell you where the bounded region is. So this is not between the curve, this is bounded region. Slightly different. Yeah.
No, it's just.
So this one you have to know how to graph. What's x squared plus 2 graph look like? Parabola? X squared move up 2, right? Is that okay? Something like this. Is that okay? What's a y equal to x graph look like? Negative x look like?
Cos of origin, slope of
Yeah. Okay, what does x equal to 0 graph look like? It's a vertical line, good. So it's a vertical line from here to here. And from here to here. So how do I find the region here, this part? Integration 0 to 1. Now what's the top graph? Minus negative x. Make sure you had to put a parenthesis there. Is that okay? And whatever the answer is, I don't know. I think 17 over 6. So top minus bottom. Now on the AP exam before, it have show up something like this in the past. You have show up something like, hey, there are 2 regions between the curve. So what I mean is like this. Y equal to x cubed and y equal to x. Now, wait. This one is kind of difficult for you guys, but what does x cubed graph look like?
Isn't it the one that?
Yeah, yeah. Good, 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 good. It looks like something like. It looked like something like. I'm gonna make it exaggerate a little bit. It's something like this. Do you remember this?
Yes.
There was another graph, y equal to x. It looks like this. Is that okay? And we know that if we set equation equal to each other, we will find 3 intersections. Because we can factor out x. And we can say that's x plus 1 and x minus 1. So x equal to 0, x equal to negative 1, and x equal to 1. So we know that it is negative 1, 0, and 1. So we know that. How do I find the area between the curve?
Zero?
0 to where?
No, it said, is it equal to 0?
No, it's not equal to 0. That's what you think is equal to 0, but it's not. Good guess. It's a terrific guess, but it's not. Okay, so let's do that. So negative 2, negative 1 to 0. Which one's on the top? This case. X cubed, good. Well, we're going to show you the x cubed, which is the black part of the graph, right? Which one's on the bottom? X, right? Is that okay? Is that hard? And then adding from where to where? 0 to 1, which one's on the top? Minus what? Use a decimal see if you can figure out the answer.
What's the? What's the? Oh wait, on decimals. You said. Oh, okay. Yeah.
happened? What's your question?
Keep going to find the negative 1 to 0 and then x is. Does he plug in the.
You can plug in 0.5 to test it. So 0.5 to the third power is smaller or bigger?
Oh, no, it's not.
0.5 versus 0.5 cube, let's say 1/2. 1/2 the cube is going to be 1/8. So it's going to be smaller. And then for the other side, because it's negative, so it
Yep,
changed.
the entire expression.
Now here's a trick. If you were smart, you're gonna say, hey, this region and this region look the same. If they look the same, can they also equal to this? 2 times that. Because if they are the same, can I just do 2 times that? Visually, we know they look the same. So we can actually double them if I have to. Now, this 2, you're gonna get the same answer. This answer and this answer are the same. You can type in on decimal, see if it's true. Because this region here is exactly the same as this one. They're symmetrical. They both are symmetricals. Is that okay so far? Now, the orientation could be different. Let's talk about different orientation. So what we learned so far is, we can do top minus bottom. Area between the curve, dx, a to b. This is area between the curve. In x perspective. You can do y perspective too. So this one's kind of different to see. This one's c to d. Why do I choose c to d? Because they have different boundary. Their y intersection is different. And it's going to be right minus left. Right minus left. So this one is also area between the curve, but it's in a y perspective. What I mean by y perspective? So I'm going to give you an example. This time I'm going to have a g of y, not f of x, is equal to 3 minus y squared. And f of y is equal to y plus 1. Now, if you don't understand this part, I personally don't think it's a very big deal because I don't think AP exam will give you y perspective per se. I think x perspective is already hard enough, but y perspective is slightly different. Now this one's going to be hard to graph, so I'm going to help you to graph it. So this one, we're going to say this one's blue, this one's red. Okay, so let me ask you a question. Let's start with the y squared. What do you think y squared graph look like? It looks like parabola. It's like go up and down. It's going to go sideways. But it's facing right or left. It's actually facing left. Just like before, this is negative, right? Samantha, pay attention to here. So this is negative y squared. So if you look at just y squared alone, this one's facing this way, right? But since this is negative, so this must be facing this way. Is that okay? And not only that, this 3 is going to go which way? This 3 is going to go what? Not down. To the right. Because in this case, perspective, you just tilt your head the other way. Think about that's 3 minus x squared. That 3 is going to go up 3. But because go up 3 is you tilt your head to the right. This should facing right 3 like this. And on the decimal, you should try to graph x equal to So on Desmos, try to graph x equal to 3 minus y squared now. See if they come out the same. X equal to 3 minus y squared. So it should give you like something like this, right? And something like this, and something like this, something like this, and something like this. So the graph's gonna be something like this way. Oops, this one should be blue. This one should be blue. Blue should be like this. Is that okay? How to graph x equal to y plus 1? What does that graph look like? If you really have problem, change it to y equal to x minus 1. Right? If I change that a little bit, this one is a red. So this one still look like this. Minus 1. Right, like this. Do you see like this? Now here's my question. My boundary is going to be from where to where? But yeah. Why is it -2? Because it's using y value here. It's going from down to up. So the way to accumulate this area is going to be this way. Is that what you said? Oh, you did? Sorry. Amelia just sounds more correct than you. When you say it, it's like, no, that's the wrong answer. When you say this right answer. I'm sorry, I didn't hear you. Does that make sense? Because this is -2 all the way to what? We're not going from here to here because there's no way to go in from here to here. The problem is this one has overlap of same graph. So this one you had to do top minus bottom here, but on the same function. And you're gonna be like, wait, that doesn't make sense because this is top, this is bottom. So you had to break to 2 sections in order to do this. So it's must using the from -2 to 1 here because we're using y perspective. So it's gonna calculate area this way. Does that make sense? I don't use the x anymore because everything in terms of y, I'm gonna use the y boundary. The y boundary, that's why it's defined as a C and D. It's not A and B. So this is the y bound. So this is the y bound. And this is the y bound. Does that make sense? Is that okay so far? And then you're gonna say, what do I type in the calculator? You type in the same thing as before, just type in term of x. So which one is right in this function? The right is the blue or red function. The blue one, so it'll be 3 minus y squared. Is that okay? Minus the left function, which is what? Is that okay? And that's it. You're still gonna get 9/2 because that's the same graph, different orientation. You realize this graph and the graph before, they are the same graph. Yes.
Is there a way to like plug in a number and see if it's right or left, like between x?
Yeah, so let's just try to do that way. So let's set those two equations equal to each other. So let's say we don't know how to find intersection. and you don't know how to graph this correctly. 3 minus y squared equal to y plus 1, right? And I'm moving everything to the other side. Guess what? That's going to give you y squared plus y minus 2 again. And this is the y plus 2 and y minus 1. And y equal to -2, y equal to 1. So same thing, this is how you get -2 and 1. How do I know the top and bottom? Yes, I can plug in. Let's plug in. If I plug in 0, what happens if I plug in 0? G of 0 is what? 3, which is on the top or on the bottom, compared to f of 0. Yeah, so it's right. So in that orientation, if you tilt your head to the right, the blue function is on the top. Does that make sense? So if you just turn your head sideways, you see that blue one's on the. So it's still technically top minus bottom. It's just you have to tilt your head right, 90 degrees. Okay, so now this is the area between the curve. We're gonna talk about volume now for the first time. So
What's the value?
9/2. They are the same graph actually. So in terms of things, how do I find the volume of? Do you guys know how to find the volume of basketball? Yeah, that's sphere. If you know radius, what's the equation for basketball? 4/3 pi r cubed. Good job. If you remember that, awesome. And if the teacher today says, hey, I want you to find the volume of football. The football is a different shapes than sphere, right? So it's any way to find a volume of football.
You put it in walk.
Huh?
You put it in walk.
That's actually smart. Actually, that's one way to do it, right? But you had to push it down, yeah, and then calculate how much it leak out. Okay, so yeah, that's a good way to think about it. So let's just say, imagine that we don't have a football, so I can't really dissect a football, but I can dissect a watermelon. So that's why where the watermelon comes in. So the watermelon is gonna have a particular situation. So let's create a situation that help you find like a, because the watermelon is not exactly a sphere either. It's a kind of like oval type of shapes. So let's just say we cut a watermelon to half, and we're gonna use this function represents watermelon. No, can you actually find a function? Yeah, you can if you do regression. If you plug in all the point of the green part of the watermelon, and you can actually ask the Desmos to give you the exact equation, and they can actually do a regression for you to go and do that. However, we say, okay, we want to find a volume of a football. So let's start with a football. Football is one word, right? So what we're going to do is we're going to use watermelon to represent the football. So this is the black part. And this is the function. And the function I'm going to use is y equal to square root x. That looks kind of like an oval-ish. Well, half of an oval at least. So it should look like something like this. It's a sideways parabola, by the way. Actually, I'm not going to use that. I'm going to use green dots. There's a reason why I use a green dot here. And we're going to stop at here. We're going to stop at right here. This is where, this is my knife cut right here. Right now, we just did that cut right now. We just did cut a watermelon to half. Is that okay? Now we have a green part. Also, we have red part of the watermelon, right? And this is the red part of the watermelon, right? Now imagine this. It's hard to imagine this, especially a lot of people don't have spatial knowledge. I take this and rotate. I take this graph and I rotate it across the x-axis. Okay, some of you guys may not be able to see that. So we're gonna try to do that, like actually. So oh, my camera's not working. Why is my camera not working? Wait. Why is nothing working? Alright. Okay. Let's get rid of all this stuff.
Why did this come from? Friendly back. Is audio working? There's no audio. Can't prove it.
All right. So what we're gonna do is we're gonna have a football. I hope I have a football. I didn't have a football. Anyway, so I'm gonna try my best to do this because my back. I was supposed to prepare last night, but my back's kind of. I need to stand up.
It's not ideal.
Oh.
Yeah, Mr. H.
You need a assistant.
So we're gonna try to cut like the football shapes, right? So.
Don't cut your fingers off, Mr. Young.
This watermelon I should put.
What did they all do? I didn't need that one.
Okay, so this is one slice of watermelon. We just only want a one slice.
That's a juicy watermelon.
They are. I might cut it this way. Cut it this way. This is not how you use knife right away.
Let's figure out what's that for. Just go over this culinary war. This is Mr. AD.
I know this. Okay, so this is the square root x graph, right?
Yeah,
Right.
yeah, sure.
So where's my drill?
It's behind you, Mr. Desk.
I'm scared.
And where's the drill bit?
It's also.
Okay.
He's gonna drill the water.
So drill bit.
Do you?
Okay, so we're gonna drill a
Yeah.
watermelon.
Oh my god.
Yeah, I can record this so I can study later. Yeah, good point, good point.
It's like
Live seems a little low. Yeah. Oh, I get it.
Oh, hey, the drill.
And you're gonna spin it.
Are you just gonna using the drill or you're?
Use it.
Yeah.
Yes.
Okay, do one.
Or he's being sent on something.
He doesn't want to
His
shot.
somebody hold us. Come here.
I know, Alex
I give you one. Never mind. What? What do you
Can
want?
you hold a chopstick for a sec?
Oh, good luck, Alex.
I
Watch your hand, dude. You're blocking the watermelon. So here's the watermelon's not moving. Mr. Yoda. He's blocking
What?
at the same time.
Is that good?
So this is what. Oops. It's not enough. Okay, so we.
I don't think how you're supposed to use it.
So this is how the rotation works. This is a square root x graph, right? Do you see this is the origin? That's the thing.
Mhm.
It's rotating around here. Oops.
He doesn't have no order. You got a couple of rotations.
That should be better.
You can see it in there.
Yeah.
Does that make sense? Well, you get a point, right? It's rotating, so it's rotating inside the curve and outside the curve. Is that okay?
Yeah.
So that's the idea. The idea is that this, but not only that, is what if I just have one slice of watermelon like this way? If I rotate, okay, if I rotate just one slice, let's just say, how do I do this? I don't know how to do this, but just one slice. If I just have this one, it's rotate one slice. What kind of shape will you see it from this perspective? Like if I rotate, it's a circle, right? So, but do you know how to find a value in a circle? Okay, so this is what we're gonna do. We're gonna find a value in the circle. We're gonna find area of circle, and we're gonna add up all the, each area of a circle. So I'm trying to say is,
That was a good demonstration, Mr. Yoda.
Yes.
Very nice.
I will now have to.
No, I think we.
so I'm gonna go back to my computer screen.
No,
So
I'll stick it.
imagine that this, right? Imagine just this slice of watermelon right here. If I cut it like just even a tiny slice, and if I rotating around x-axis, and this x-axis is gonna rotate like this. Does that make sense? So, huh?
Do you not want to be on camera?
I'm just wondering, like.
Yeah, it's out here. So if I just have one slice, and if I rotating on this axis right here, this slice is gonna form a shapes that looks like this. And this shape is a circle, right? Even though I cannot show you that this is a circle, but it's a circle because I here is we doing one dimensional. It's hard to show you like two-dimensional perspective. So what calculus told you says, hey, we can use that. We can say, well, we know area of circle is, what's area of circle? Is equal to pi r squared, right? We know pi r squared. And I hear the r is the distance from here to here. Because r is changing. R changing from I here very close to the tip of the watermelon, the r is less, right? And r is getting more when I go into the center of the watermelon, right? So can I say that I have an integration of pi is a constant. We can always take a constant out. And we can say this is a function of r of x. Why is r of x? Because this function is based on the height of this slice of watermelon. And I can do square. And when do we stop? We stop at 0 and we stop at 4. So it'd be 0 to 4. So it's from A to B, sorry, from A to B. So this is well known as called disk method. Because every slice is a disk. Every single slice. So in terms of this is gonna be area of a circle, which is here. We're using something called disk formula. But this formula is basically it's gonna be integration for this particular situation from 0 to 4. Is that okay? What's the radius here?
It's gonna be 2.
Well, it's changing. It's not a constant, right? So what would it be? Thank you. Why square root x? And Cameron explain why square root x is my radius?
Watermelon is just the graph of the square root of x.
Right, but the height here, right, is changing, right? Here is 1, here is a little bit square root 2, here is 2, right? It's changing based on the functions, right? The function is square root x. So can I plug in x in there? And I can find out how long the radius is. Does that make sense? Now we forgot the square because we need a square. And we also forgot a pi in the front. And we also forgot a dx. Is that okay? So can we just figure out this? This is really quickly. So 0 to 4 pi, this one's x dx. And this one's going to be x squared over 2 from 4 to 0 times pi, right? And that's equal to 8 pi. So we find a volume of a disk. You say, I don't believe you. That's fine. You don't have to believe me. You don't have to believe me. We know a volume of cone, right? 1/3 volume of cone is 1/3 pi r square h, right? Okay. So 1/3 pi r square h. So how do I, using the disk method, to find out a volume of cone? What kind of equation I should use? Straight line, thank you. Why do I do straight line? And let's say this straight line is maybe 1/2 x, like this, right?
Basically triangles.
Like a straight line. If I take this, and if I rotate, according to x perspective, what kind of shape am I going to form? A cone. Now, we know this side is 4 and this side is 2, right? Can you use geometry to find the volume of this cone? Can you use geometry to find the volume of this cone? We know the radius is what? 2, right? So it's going to be 1/3 times pi times 2 squared. What's the h? 4. Okay, so that is going to be 1/3 times 4 times 4 pi, right? 16 over 3 pi, right? Now we know this. Now, what's a function of this one? What's a function of this one?
Say that one more time.
What's a function of this black line here?
Oh,
Y equal to 1/2 x. Can you use this method to find the value of this? Can you use this method to find the volume of these shapes? And try to see if you find out the answer is 16 over 3 pi. anybody got a same answer or no? According to the volume there, I got 2 squared, so it'd be 16 pi over 3. 14 pi over 3?
I got 16 over 3.
Huh?
I got 16 over 3.
So we got put pi outside, right? What's my radius? What's a radius?
2.
It's 2? No.
What happened?
1/2 x.
Yeah.
And this is a square, right? From where to where? 0 to 4. Okay, so that's equal to pi 0 to 4. This is 1/4 x squared dx. Is that okay? X cubed over 4 between 4 to 0.
Oh, X over 12.
Yeah, wait, so
X cubed over
You gotta
3, 12. Yeah, 12. Yeah, you're right. Thank you. And it'll be 0 to 4. I mean, that's not 0 to 4. This is pi, right? So pi times 4 to the third is 64 over what? 12. Can I divide it by top and bottom by 3? Wait, by 4, sorry. So this is 3. 4 is going to be 16 pi. Geometry and calculus match up. Does this make sense? Is this okay? Good. So let's call this method. We're going to talk about what's a washer method.
I'm gonna ask one minute.
Yes. This method is okay. You want to try one or no? Let's try one. Let's try one.
Be like,
We only have 20 minutes. Okay, we're gonna go to washer then. Washer method is different. Washer method is gonna be a big radius. So we're gonna start with a circle, area of circle, right? I don't know. Area of circle, and we're gonna start with a small area, have same center, and this is the same center. I'm gonna try to do my best. How do I find the area here?
find the area.
Okay, so let's just say there's a big R. We're gonna call this a big R, and this small r right here. How do I find out the area of the shapes? This is called a washer. A washer is not like a dryer and washer. No, the washer is like the tool you're using for like screw things in is a washer. Okay. How do I find this area of the shaded region? Pi big R squared minus the pi R squared. And this R is going to be the big R right here. Is that okay so far? Then you say, okay, well, what's a washer method? Washer method basically says the same thing. Washer method just says, hey, this is going to be integration from A to B. The big R square of x minus the R square of x dx. And there's a pi in the front. Is that okay?
Mhm.
Now, which kind of situation you have this? Well, let me give you an example. Let's just say today I have we're gonna create a situation here. I think it's this one. Nope, this one. I'll send you a link for you to play with. This one. Okay. So
What is that?
so I hear we're gonna have a different view here. So A is gonna be right here. Okay. So we're gonna get to 0. This is 0. Okay. So and this is 0. Okay. So now we have a graph. Now this time I'm gonna rotate around x-axis. Still. Okay, so can you visualize what this graph look like rotating around x-axis? Looks like what? A cup. What's inside a cup? It's like a cone, right? It's like a cone that's taking out of it, right? Okay, it's like a cone. So then you say, okay, well, if it's a cone, I need to find the value of a watermelon. Josephine, are you okay? He's zoning out. You pay attention? Okay. The volume of a watermelon first. Well, we know it's a watermelon, right? Because that's the square root x graph. Wait, is that square root x graph? Yeah, square root x graph. And we take out 1/2 x. Yeah. And then what I'm going to do is it's hard for you to visualize the shape. So I'm going to turn the perspective a little bit. I'm going to turn the alpha about right here. Maybe right here. And we're going to rotate around here. So that's going to form that rotation of that watermelon, take out a cone. Am I confusing you? It's okay, right? And you say, okay, well, how do I find this volume then? Well, we know that the function start with square root x like this, right? And we say we're going to take out this. We're going to take out this. And we're going to rotate. Guess what? There's 2 radius, right? There's a radius from here to here. And you have to take out the radius from here to here. Is that okay? So there's a blue radius and there's a red radius. And we know that the function here on the top is a square root of x. And the bottom here is y equal to 1/2 x. Can you find out the volume of this rotation using calculator? Today, I just want you to use calculator. Okay, I just want you to use calculator.
Everything from 0 to 4. That's the hardest.
Yeah, I just make easier for you.
I'm gonna find 0 to 2.
I have no idea. But the setup should be pi a to b. The big R is square root x squared, right? The small r is 1/2 x, right? And that's it. I don't know what it ends up to be.
Is the second is a little or not square?
Yeah, square, yeah. I thought it was square. Thank you. So what does it end up to be? What? 8 pi over 3? Okay. Is that okay? Now here's, I'm gonna ask you a hard part now. Okay? I keep on using the same graph so that make sure you got understand this. This one's maybe the hardest one today. It's hard to visualize the shapes. Now, instead of rotating around x-axis, we're gonna give you a rotate around y-axis. First of all, think about what kind of shape this got formed.
No, they're like the flower in the sea. Like a bagel.
It's like an inverse semicircle.
Like a bagel. A bagel.
Bagel has this bagel has no hole.
Bagel with
No hole.
No whole
And
bagel.
it technically has a hole. I'd say something like a.
If it's rotating, it has like.
I mean, if you cut,
It's
there's not really good.
I think I'd say something like an inverse.
What?
There's not really a good real world example for this one. With a
Without
with a sharp. Unless you got like, man, it's like a lot of what kind of bagels do you eat? What kind of cute bagel?
Okay, so it's gonna rotate around here, so both sides can rotate inside and outside. I think the one that's close to that one is this one. No, this one's not rotating around y-axis, so it cannot rotate on y-axis. Okay, so here's the thing. This one's hard is because it's in a y perspective. Before, always slice, this R is always here, right? Do you see all this R is right here? And this R is right here. This time the R is different. This time R is where? It's R is 4. Well, there's two type of R here. There's a big R and small R here. Mm-hmm. No, there's two different R.
Oh yeah, but like it's the second word.
So this is a big R. Of Y actually is not R of X this time because this is a distance from Y. So this is sliced all the way to the end. Is that okay? And there is a slice from here to here. And you're like, wait, how do I get that? That's kind of hard, but that's okay. So we know this is still y equal to square root of x. The important thing is convert this to y. So how do I convert this to y? That means you solve to y. So it'll be x equal to y squared. Does that make sense? Now, so there is a big R of y. So that's it's always what? Big R of y is what? Always 4. Doesn't matter it's where, it's always 4. Does that make sense? The small r of y is right here. What is it? The function. What's the function? Y squared. Now, where do I do integral from which value to which value? Be careful. Think about it before first. Think about which value to show integral. I know you know. I need to like maybe Sydney. See, what do I do integral from which value to which value? Or maybe Samantha? No? Neha? Why is it 0 to 2? You look at the y value and you stop right here. You stop taking integral right here. Because you only rotate around from this piece to this piece, right? So it's going to be 0 to 2 pi. You know why 0 to 2? Because this is where we stop. Right? This is C to D, right? What's big R here? Good. What is the small r here? And you're gonna get an answer of this one. Yeah, we need a square. Sorry, I did. And this is called a washer method. What'd you guys get? And you're gonna say, is this okay or no? No? Samantha? What's wrong? Which graphing? Okay, so do you understand that this is y equal to square root x is like this? And we stop right here because we should say it's x equal to 4. We stop there. And we say rotating x-axis, probably, and we're rotating around y-axis. So if I'm rotating, I'm gonna form like a kind of like a donut with no hole in there. But except there's on the edge of a donut, it's like straight edge. So it's kind of like probably more like a very weird rim. A lava cake or bun cake.
Or maybe like a watermelon and you just kind of like have fun out on the like just like mess around.
Yeah, I don't want to use knife on that one. No. Yes. Yes. Huh?
Give an example of x equals 6.
X equal to 6. We can do that.
Cameron wants a bite.
You not a slice. That slice has a drill bit in there. Maybe a different slice. Huh?
Take the drill one and iron deficient.
Iron deficient. If you die, it's not my fault. Sign a waiver. Sign a waiver right now.
I'll come shake your hand.
No. You're gonna sign a waiver. You can sign a waiver that says Mr. Ye did not give you permission to eat a watermelon, but you eat it
No, not to
anyway.
eat the water. Just pull the drill. Pull the drill.
Okay, but visualization, does that make sense?
Yeah.
Now the calculation will be kind of hard, so we're gonna have to spend like, a couple days to work out a calculation, because by the end, the idea is I want you to be able to work with off-axis rotation as well. So what I mean by off-axis rotation is, what if today I take this graph, not rotating by x-axis or y-axis, but rotating at x equal to, let's say y equal to -2. Okay, so this becomes a little bit harder. Okay, so ideally later I want you to be able to rotate around let's say it's y equal to -2. So this is axis rotation. Okay, so now what kind of shape am I gonna form this time?
That's another. It's same line.
What? Is it look like what?
Wait, what?
It's
What is it? What is gumdrop?
It's like,
Oh, yeah.
it's like a, it's, this time it's almost like a bagel. It's a little closer to a bagel.
What? No, it's not.
it's like a watermelon.
Yeah, it's
but you
got a
take out the
hole.
center.
It's not.
It's like a watermelon, but you take out a cylinder in the middle.
Oh.
It's got a hole.
Thank you.
Okay, so it's rotating here. Then this comes some more steps to it. I don't have enough time to go through this, but just kind of see the way kind of the other side is gonna form like this.
Would you combine both methods?
It's rotating. No, you're not combining both methods. You still, this is actually a washer, still, and it's gonna be a little bit hard. How much time I have?
2 minutes.
I don't have enough time. We stop right here. We don't overwhelm you, but we want you to think about it a little bit.
That's gonna be this quarter.
Probably not because of the way schedule is gonna work.
Yeah, can we come get some watermelon?
If you know how to use a knife and don't cut yourself, it's fine.
Alex, sit down. You're too young to use a knife.
If you cut yourself,
Made in Thailand. Mr. Ye, can I hold
the way he's holding a knife is pretty scary.
Mr. Ye,
Serial killer.
Mr. Ye, can I pull the trigger?
Alex, do you want his hands?
Sure.
Oye, la última semana.
My hand between.
The problem is I did
I'm
it
not
wrong.
touching that, friend.
I'm doing it for me.
I really expected it to happen.
It should hurt if I use a drill bit and I just stuck the chopstick to create more friction instead of drill the chopstick in there.
Just take the whole thing.
Is it good?
You don't have to feel like
It's not good.
That one's it's a little underlined, but it's fine.
Are you gonna reuse the watermelon?
Huh?
Are you using
Mr.
it
Ye,
for
I'm
the
going to
pasta?
go with a giant chunk of
I'll
water.
probably bring 2 other watermelon. The watermelons cost expensive.
What?
That's a huge ass watermelon, man. Are you gonna shove your face in there?
No, you didn't
Like,
get it out of it. It's probably
Yeah, he wants that back by the end of the day.
Oh, wait.
He wants to go back by the end.
that's fine.
Mr. Ye.
Wait, Brian, let me look into that. Let me steal the knife right quick.
Is there homework or?
Got a chef.
Yes.
Is there homework? Yeah, alright. I'll see you after school then.
Thank you for the water.
Bye,
Okay.
guys.
Drink more, Mr. Ye. Drink more, drink more, drink more.
No, no, this makes me learn more. We need to do more like this. Straight ahead.
Hey, hey, we're gonna find a volume of donuts. You gonna bring donuts?
Oh, Mr. Ye, I might also have to let Apple know as well. We might have to take the test can be on. You said Thursday, right? Me and Apple might have to take it like Wednesday.
We'll see what happens. I'll let you know how far we get to.
Okay. Okay.
What
Mr.
Thursday?
Ye.
Thursday, like the connectivity day thing.
It is.
No. Bye, Mr. Yang.
Bye.
I'm gonna take the stuff.
You hungry?
No.
Bye.